Welcome to Using Counting in Probability. So for this one, we are going to use everything that we've learned so far. So we know that the probability of an event is the number of favourable outcomes over the total number, or the number in the event over the number in the sample, which is the sample is the whole, all the outcomes available. We're going to use, remember our current videos, which is when the order is important, we use NPR. When the order is not important, we use NCR. And if the order is important, we're going to wonder whether it's repetition allowed or not. So if it's not allowed, then we can use the factorial. If it is allowed, then we've got to come up with some other way to do it. So from a past HSC, so we've got, Sophie's got 5 colour blocks. She's got a red, a blue, green, yellow and white. She's going to stack in 2s, 3s, 4s and 5s on top of one another. So when you consider this, if we're stacking the blocks in order, that's like lining up in a straight line. So that's going to mean that order is important. So because it'll matter, especially with the stack of 2, if we take, for example, one, if the blue's the bottom one and the red's above it, or the red's the bottom one and the blue's above it, that is actually a different order for a stack. So we're going to have a look at how many different towers she can make from the 3 blocks that are 3 blocks high, how many different towers she can form all together, and then the probability that in the stack of 5 the red and blue are next to each other. So the first one, so order is important, and we're choosing a stack of 3 from the 5 blocks, so that's 5p3. So that's 60 different ways that she could actually stack the have a stack of 3. How many different? Well, for the different ones, we've got to do all of them. We've got to do the stack of 2, 3, 4, and 5. So stack of 2, you're choosing 2 from 5, so that's 20. Stack of 3 we did before is 60. Stack of 4 is 5p4, which is 120, and stack of 5 is 5p5, which is also 120, giving us a total of 320 different ways that she can actually stack the blocks. So what about the probability that in the stack of 5, which we had in the last answer, the red and blue block are next to each other? So remember that the stack of 5 from part B was 120 possibilities. So that's going to be our possibility underneath. If the red and blue are together, that's 2 factorial. And then the other 3, as well as them considered as a group, make 4p4. So we're stacking 4, a stack of 4 from the 4 that are left. And so that's 2 factorial times 4p4, which is 48, which is 2 in 5. Also from for a second example, is also from past HSC. So we've got Mr. and Mrs. Roberts with their 4 children. They're going to the theatre. They're given 6 seats next to each other in a single row. So in a row, seating is obviously important. So it matters whether you're the first or whether you're last. So therefore we're going to use permutations. So the probability that the 4 children allocated seats next to each other means we're going to look at grouping the 4 children together as one. So total weight of all 6 of them is 720, and we need that because we're doing probability. The 4 children together is 4 factorial. The group of children and the parents, so the children are considered 1, 2 parents makes 3, so that's 3 factorial. So therefore it's 6 times 24 on the top over 720, so it's a 1 in 5 chance the children are sitting, or 4 of them are sitting together. So for our third example, we're going to have a rowing team which consists of 8 rowers and a coxswain, where the rowers are going to be selected from 10 students in year 12, and the coxswain is going to be selected from the 5 students in year 11. So first one is how many ways can we select the team, and the second way is what's the probability 2 friends, Jim and Kim, who are in year 12, make the team. So the first one, so In this example, we're choosing 8 rowers from 10 students. Now the order doesn't matter, because it doesn't matter if you're the first rower chosen or the 8th rower chosen, you're on the team. So therefore we can use combinations, so we can use NCR, and we're choosing 8 rowers from 10 and 1 coxswain from 5. So the total is 10C8 times 5C1, which is 225. Now this total will be important in the second example because we're finding probability. So in the second one, probability that 2 friends, Jim and Kim in year 12, make the team. So we're going to assume Jim and Kim are in the team. So that leaves us 6 rowers to choose from the 8 that are left in year 12. And we still have 1 coxswain being chosen from the 5 in year 11. So probability that Jim and Kim make the team is 8C6 times 5C1 out of that 225. So they've got a 28 in 45 chance of making the team. Thank you.